You have two cars that are 276 miles apart. Okay, so you have to understand that. And they're coming towards each other. Okay, and that's after 6 hours of traveling, right? After 6 hours of driving, this car and this car are going to meet. Okay, so and it says that the rates differ by 5 miles an hour. So one car travels a little bit more because he's a faster car. So what do I know about this distance from this car and this distance? So whatever this car travels and whatever this car travels, it's going to equal 276. And that's what you're going to use to set up your equation. So let's set up the information that we need. So we got, let's call it slow and the fast car. We have R, T, and D. Remember, distance is rate times time. Right? The rate, the speed that you're going to, times however long you're driving for. So the speed of the slow car, we don't know. Let me see. Travel. Okay, so it's different, right? So this one, so you can call, if you call the fast car R, the slow car would be R minus 5. You can do it that way. Okay. Now, if you want to call the slow car R, the fast car would be R plus 5 because he's going to be 5 miles faster. So it really doesn't matter. So pick one, whichever one you're comfortable with, and stick to it. So I know that time-wise, they are going to drive for 6 hours. So remember, distance is rate times time. Right? So right now, the distance is going to be expressed as the product of the rate times time. So distance, in this case, for the slow car, R times 6 is going to be 6R. The distance for the fast car, we're going to do this really properly. You're going to get 6R plus 30. So if I asked you right now, what is the distance traveled by the slow car? It'd be 6R. And the fast car would be 6R plus 30. So before, when we started the problem, remember, you have to understand it. So what do I know about their distances? Well, if I take the distance driven by the slow car, which is 6R, the distance driven by the fast car, which is 6R plus 30, that is going to equal 276. And that's my equation. Combine like terms, plus 30 equals 276, minus 30, minus 30. You're going to get 12R equals 246. Divide both sides by 12. And R, I believe, is 20.5. So the slow car is driving at 20.5 miles an hour. The faster car is 5 miles faster than that, so the faster car drives at 25.5 miles an hour. Yeah, that's really it. 4. Again, we have two cars going, or two things traveling towards each other. So this is going this way, and this is going this way. Right now, we know that the distance is 195. Sorry, not 195, 95. That's the other problem. It's 150 miles an hour, 150 miles apart. So I know that the distance covered by A plus the distance covered by B will equal to 150. So there is your equation. Let's call this A and B. A went at 20 miles an hour. B we don't know, so we're going to call that R. We don't know the rate. So R, T, that's T, that's D. Time-wise, it says that they both traveled for 5 hours. So, and this car also traveled, or vehicle or whatever, traveled 5 miles an hour. So think about it. Distance is R times T, right? So if you travel 20 miles an hour and you do that for 5 hours, guess what? Your distance that you cover is going to be 100 miles. The bottom one, 5 times R. Unfortunately, I don't know the speed, right? So the distance here is going to be written by the expression, described by the expression 5 times R. So again, like I said, what do I know about these two distances? Well, the distance covered by car A, which is 100, plus the distance covered by car B, which is represented by 5R, that's going to equal to 150. Subtract 100, so now this becomes the tedious part. That goes away, 5R equals 50. Divide both sides by 5, and R equals 10. So the speed of the slower vehicle is going to be 10. 6, 2 automobiles start at the same time but travel. So this time we have 2 cars, one going this way, one going that way. Okay? One's going at 25 miles an hour, and the other one's going at 35 miles an hour. They're going to do this for a certain amount of time. And then I'm going to say stop. So this car travels all the way that way, and this car travels away. I'm going to say stop. So they stop here, and I measure the distances to see how far they are, how far apart they are. And it says they're 180 miles apart. So they started here, right? Now, the question is, so for how long do these two cars travel in order for them to be 180 miles apart? So that's not too bad. So that's 6. So let's call it again the fast and the slow, or the slow and the fast. The slow one is driving at 25. The fast one is at 35. RTD, that's a T by the way. We want to know, I don't know the time. They both are going to drive for the same amount of time. And the distance, again, is the product of R and T, so 25T. This one's 35T. So the distance, so if I ask you how far did the slow car travel for, well, you're going to say, as of now, 25T. And the faster car traveled 35T. So what do I know about the distance? Well, I know that the distance of slow car, which is represented by 25T, plus the distance of the faster car, represented by 35T. If I add those two distances, it should equal 190 miles. That's 60T equals 180. Divide both sides by 60. T equals 3. So both cars traveled for 3 hours. So let's see if this makes sense. So both cars traveled for 3 hours. So if you're driving at 25 miles an hour and you drive for 3 hours, you're going to travel 75 miles. If you travel 35 miles an hour and you drive for 3 hours, you're going to drive 105 miles. So that means that the slow car went this way, he traveled 75 miles. The faster car went this way, traveled 105 miles, right? And after 3 hours, I said stop. And we measured their distance that they're away from each other, and notice 75 plus 105 equals 180. We know we are correct. What's next? 8. A man walks. So at 4 miles an hour. How far can he walk into the country and ride back on a trolley that traveled 20 miles an hour if he must be back home 3 hours from the time he starts? So you got to understand the question. So here's the guy, right? He's going to walk. And then on the way back, he's going to take the trolley. I don't know. Oops. I should point that the other way. So, trolley. I don't know how to draw a trolley. Right? So, he's going to walk. So, how far? So, the thing is, this whole trip has to take 3 hours. Right? So, how far can he walk? Can he walk up to here? Can he walk up to here? How far can he walk so that when he takes the trolleys and goes back home, the whole trip takes 3 hours? So think about it. If he walks too far, right? He walks too far and then takes the trolleys from here to head back home. Maybe he won't get back home in 3 hours. So he can't walk that far. So he has to figure out how far he can walk because he only has exactly 3 hours left. So this distance is what we're trying to find. How far can we walk, right? So let's call this walk and let's call this trolley. RT and D, RT and D. So his walking speed, do we know his walking speed? Yes, it's 4 miles an hour. The trolley will travel at 20. So he's going to walk 4 miles an hour that way and come back at 20 miles an hour. The whole trip is going to take, 3 hours. So how long did he walk and how long did he take the trolley? Well, I don't know. But I know that if he walks for T hours, right, the trolley part of the trip will take 3 minus T because the whole thing took 3 hours. Right? Find the distance. 4 times T is 4T. Do a little distributive property here. We get 60 minus 20T. What do I know about both distance? The distance that he walks and the distance that he takes the trolley to come back. They're equal to each other. That's your equation. 4T equals 60 minus 20T plus 20T on both sides. We get 24T equals 60. Divide both sides by 24. Right, T, well, let's simplify that. So that's going to be divided by 12, 5 over 2, or T equals 2.5 hours. So The amount of time that he spends walking is 2.5 hours, and the amount of time that he takes the trolley, obviously, is going to be 0.5 an hour or 30 minutes. So, but that doesn't answer the question. How far can he walk? So, he's walking at 4 miles. So, if he walks at 4 miles an hour and he does that for 2.5 hours, what is the distance that he walks? He walks 10 miles. So that means that he walked 10 miles, right here. I'm going to write 10 miles. And stops and then takes the trolley back home, and that takes exactly 3 hours. So if he walks more than 10 miles, unless I decide to walk for 12 miles or something, if he takes the trolley home, he's not going to make it in 3 hours. So 10 hours is how far he can walk. Yeah, was that 9? 10. Motorboat leaves the harbor and travels an average speed of 15 miles towards an island. So here is a boat. Here's the island. So here's the island. And travel, so going that way towards the island, it's 15 miles an hour. Okay. The average speed on the return trip, so going back, is 10 miles an hour. Okay, so notice that. And then how far was the island from the harbor if the total trip took 5 hours? So this whole round trip took 5 hours, right? So let's say going to the island and coming back. So those are the two parts here. So going to the island, his speed, I guess because he was with the current, was 15 miles an hour. Coming back, it was 10 miles an hour. The time that he took, the whole trip took 5 hours. So we don't know exactly how long it took him going, but let's call the time that he travels going to the island T. The coming back, well, I know the total was 5 hours, so the coming back was going to be 5 minus T. The distance column, multiply those two, we get 15T. Here we do this 3D property, we get 50 minus 10T. What do I know about their distance? The distance going to the island, coming back from the island is the same. So and that's what I'm going to use to set up my equation. So 15T equals 50 minus 10T. There's variables on both sides. Get rid of this variable. Let's do plus 10T. We get 25T equals 50. Divide both sides by 25. T equals 2 hours. So going towards the island is 2 hours. And coming back from the island equals 3. That makes sense, right? Because you're at a little slower speed. 12. Part of his flight training, student pilots were required to fly to an airport and return. So let's make an airplane. Got an airplane? Okay, here's the airport. So he's here. He's going to fly to the airport. And then he was going to come back. Find the distance between the two airports if the total flying time was 7 hours. So again, going was, let's say, 90, and then coming back was 120. I guess you're going with the wind and against the wind, or against the wind and then with the wind. So let's call that going and then coming back. So very similar to the previous question. So let's see what we can. So going, he was traveling at 90 miles. Coming back, he was traveling at 120 miles. Time, did we have time? We know that the whole round trip was 7 hours. So again, I don't know. I know it was total of 7, right? The going and coming back total of 7. So let's call the going T, which means the coming back will be the total 7 minus T. The distance is going to be 90T. Here we're going to have 840 minus 120T. So now I'm going to use that information to set up my equation. I know that the distance going to the airport, coming back to the airport is the same, so 90T, right? That distance equals the bottom one. What do you call plus 120T on both sides? That goes away. We have the 210T equals 840. Divide both sides by 210. And T equals 4. So that means that going to that airport, it took him 4 hours. And coming back, 7 minus 4, it took him 3 hours. Now, I'm going to take that information and substitute here. So the distance going was 90 times t. Now that I know what t is, 90 times 4 is 360. Now, I'm going to if you substitute 3 here, right? Multiply that by 120, you should also get 360 because both going and coming back is the same distance. So let's just try it out. 840 minus 120 times 3. 8 times 3 minus, sorry, 840 equals, minus 3060, and then 840, we have a problem here. Doesn't look correct. Doesn't look correct. No, it looks fine. It's 360. No, it's fine. 7 minus 4 is 3. But why am I getting... Hang on, guys. I'm just trying to figure something out. I get 360 on the top. 120. Sorry. Minus 840. 480. Why am I getting 480 on the back? The answer is 360, by the way. Okay. The distance is 360, but something's not. The average street from was 120. Right, this is between the two. Well, let's just hold on. I'll come back to this. But the answer is 360, the distance between the two airports. Did I do something wrong? 14, 840 minus t. All right, I'll come back to this. What number was that? 12. Something's off. 14. A man travels at 5 miles an hour after traveling for 6 hours. Another man starts at the same time following at the rate. Oh, okay. So that's the same question. So we have two guys. Let's call it the first guy and then the second guy who starts after. The first guy is traveling at 5 miles an hour. Okay, after traveling for 6 hours, another man starts at the same time. So this guy here, he's driving t plus 6, right? And the second guy travels at 8 miles an hour for t hours. When will the second man overtake the first? Okay, so that's a setup. That's the example I used in class. So this is 5t plus 30. This is 8t. So what do I know about their distances after once the second man catches with the first? I know, well, the distance that they travel is going to be the same. So it's going to be 5t plus 30 equals 8t. Let's get rid of the t because there's t on both sides. That goes away, and left is 30 equals 3t. Divide both sides by 3, and t equals 10. So the second guy has to travel for 10 hours, and the first guy walked 16 hours. And what's the question here? When will the second man overtake the first? Well, what do you call it? The second man will overtake the first in 10 hours. Okay. So remember, let me see if I can go back. So here's the first guy. He's traveling. He's doing this for 6 hours. Okay. And then the second guy, okay, starts the second clock. So when when the second guy starts traveling, guess what? The time-wise, the first guy has already what do you call been walking for 6 hours. So the second guy, and I wish I could do this with two. I can't draw it. But the second guy, the clock starts, right? And then the second guy catches up to the first. So time-wise, right? The first guy travels for 6 hours plus this extra time, and the second guy travels for that amount of time. Okay. Let's see. So, well, we got the answer for that one. 16. I think is that the last one? No. Yeah, 6. No, two more. 16. Long distance runner is on a course running an average 6 miles. 1 hour later, second runner began the same course at an average of 8 miles an hour. How long after the second runner started will the second runner overtake the first one? So same. So let's call this the first guy running, and then the second guy. So the second guy starts. The first runner starts out first. So the first guy, he has a speed of 6 miles an hour. 1 hour later, okay, so I'll get to that in a second. So the second guy has speeds of 8 miles an hour. So the first guy it's been running for 1 hour and then plus t. All right, the second guy is just been running at t hours. Right, so the first guy has been running for 1 hour more once before the second guy even starts. Okay. So what is the distance? Well, distributed property, you get 6 plus 6t. Here you get 8t. What do I know about the distance of the first runner and the second runner? Well, it's going to be the same, right? So the first one is going to start running, and the second guy is going to start running 1 hour after. But once they are at the same level, look at the distance side to side, the distance is going to be the same. So here's my equation. The distance of the first runner is going to equal the distance of the second runner. Minus 6t. That goes away. 6 equals 2t. Divide both sides by 2. T equals 3 hours. What was the question? How long after the second runner started will the second run overtake? So it's going to be 3 hours after the second runner starts. Okay. I think one more. Jet plane traveling at 600 miles an hour overtakes a propeller-driven plane which has had a 2-hour head start. So, okay, so let's call this jet. Let's call this propeller. You ever been on a propeller airplane? I have. It's kind of scary. So the jet is traveling at 600 miles an hour. Wow, that's pretty fast. RTD. And the propeller plane has had a 2-hour head start. So the propeller plane has 2 hours plus t. The propeller is driving at 200 miles an hour. It's been on the air for 2 hours more. So the jet is going to be t. The propeller is going to be t plus the 2 extra hours. How far from the starting point does the jet overtake the propeller driven? Okay, so d is going to be r times t, or 600t. This is going to distributed property, so 200 times 2 is 400, and then 200 times t is going to be 200t. The distance from when the jet overtakes the propeller, their distances are going to be the same. So 600t equals 400 plus 200t. Subtract 200t from each side, and I get 200t equals 400. Divide both sides by 200. T equals 2. So, what was the question? How far? So, oh, wait a second. How far? So, if t equals 2, the jet propeller is going to be 600 times 2. He's going to have traveled 1200, but that's not matching. What number is this? 18. I'm getting 600 here. Hang on a second. 2 plus t, head start. Propeller given a try 200 miles, so. Okay. 400 for 200 t. That's because I can't do my equation. So, hang on. Here's my mistake. Erase that and decide before you start yelling that I made a mistake. Give me a second. So, going back to this. So, here's my mistake. So, 600 minus 200. I wrote 200. 600t minus 200t is actually 400t. Equals 400 on this side. Divide both sides by 400. T equals 1. So, in 1 hour, the jet plane catches up to the propeller train. So, if the speed of the jet is 600 miles an hour, and you multiply that by 1 hour, because that's how long he was flying for, 600 miles. So, how far from the starting point? So again, here, the starting point would be 600 miles. Okay. All right. Hopefully I didn't make it too complicated.